Hi, so let's understand about page swap time saving. Okay, so first of all, as you can see, this is your main memory. Okay, and in the main memory, only P0, P4, P3, and P6 pages are stored from the process that is stored in the disk. Okay, and this is a page table that stores the mapping between pages and frame number. Okay, as you can see, P0 is stored in F0. So this is the mapping that is mentioned here, and this is a valid bit column, so that stores if the frame number that is stored here is a valid or not. So you can see here, any random value can be stored here. Okay, but here the frame doesn't, here the frame number does not actually exist. This is basically a garbage value. Okay, so therefore the valid bit is marked as 0 here. Okay, so now let's see, if the CPU requests a page number p, let's say p5. Okay, CPU requests this page number p5. Now so first of all, CPU requested p5, but p5, uh, but the valid bit for p5 is v0. That means p5 is not in the main memory, so it has to be brought from disk to main memory, but there is no available space, you can see, in the main memory. So now which page has to be replaced? So that's a different topic, and there are page replacement policies, and any policy can be used to determine which page needs to be replaced. Okay, which page needs to be replaced. So for now, let's assume uh, P0 needs to be replaced. Okay, P0 needs to be replaced. So now can P5 simply go and overwrite the page, overwrite the content that is stored in frame 0? Can it do that? So there, so it can do that. Yeah, because P0, as you can see, page 0 is already uh, stored in the disk permanently. So there is no harm if I simply go and overwrite the uh, page 0. Okay, if I overwrite it with page 5. Okay, so that will also save my time if I in replacing the page. Okay, so but there can be a case in which the page can be modified, the page content can be modified. Okay, so let's assume by any means somehow the page content is modified. So P0 was modified. So therefore, when you try to replace the page P0, then you have to know if the page content has been modified or not. Has it been updated or not? If it has been updated, then I would have to put back my P0 to the to the secondary memory, to the disk, uh, so to reflect the changes correctly. Okay, but if the page P0 has not been modified since the time I have loaded the page into main memory, then I do not need to put back the page. I will simply overwrite the new page with the old page. So in the previous scenario, P5 could override the page 0 in frame 0. Okay, but if the content was modified. Okay, so now let consider another page. So let's say P3. Okay, so P3 was modified. Okay, so now let's assume another scenario in which CPU requested, let's say P, which page was not available, P7. So let's say CPU requested P7 page, and since since as you can see here, the valid bit is 0 for P page, so P7 page. So for P7, valid bit is 0. That means a page fault has happened. So now, but Can it override? Can P7 override P3? No, because P3 was modified. Okay, page was modified. So P3 had to be put back, okay, into secondary memory, into disk. Okay, so now how do the operating system know if the page was modified or not? For that, there is another column that we can add in page table, and that column is basically a modified bit, that is called a modified bit or a dirty bit. Okay, and this bit is used to know if the page content has been modified or not. So for all the pages, so for all here you can see it is 0, but which page was modified? As you can see here, P3 was modified. Okay, so for P3 it is modified. So sorry, it is 1, it is modified, and for all other it is not modified. So now from this value the OS can know that the page was modified. So there is a need for, so uh, first was put back the page number P3 into secondary memory, and the second step is then bring the new page, which was the new page here, P7, into the position of P3. Okay, so this is how it happens. So here you can see using modified bit, you have saved the time in swapping the page. So if the page is not modified, if you can see here the modified bit is 0, then you can simply avoid the first step, that is to put back the page into main memory, sorry, secondary memory. You can skip that step, and you can simply bring the new page into uh, the older page's position. Okay, so using modified bit you have saved saved the time in swapping the page. Okay, in swapping the pages. So this is what we call page swap time saving. So here we have added a new column in the page table which is called modified or dirty bit. If its value is 1, that means your page content has been modified. That means your page content is modified. Okay, so that was all about page swap time saving.